Hello everyone, welcome back to our channel. This is third lecture on differentiation. Using first principle. Let us just revise what is first principle. If there is any function f of x, then the derivative of that function is denoted by f dash of x. It is given by limit h tending to 0 f of x plus h minus f of x upon h. In the previous class, we already solved two problems. So before we begin with the problem number 3, remember that for finding this derivative, that is f dash of x, I'll need two things. I'll need f of x plus h, and you will try to eliminate h. Which h? The h over here. Reason? Anything divided by 0 is not defined, so try to eliminate the letter h over here. So let us begin with the third question. Exercise 1, question number 3. The function is root sine x. So what do we get? F of x is square root of sine x. So to find derivatives using first principle, I need f of x plus h. Okay. So what is f of x plus h? Root sine x plus h. So first of all, let's write the first principle. F dash of x equals to limit h tending to 0 f of x plus h minus f of x upon h. So just put the values of f of x plus h. What is that? Square root of sine x plus h. F of x is square root of sine x upon h. So for now we have just put the values of f of x plus h and f of x. Now what we are going to do, we will try to eliminate the square root sign over here and over here. How that can be done? Limit h tending to 0, first we'll write the given thing, root sine x plus h minus square root of sine x whole thing divided by h. Just multiply this with root sine x plus h plus root sine x. Divide this by root sine x plus h plus root sine x. Okay. Divide and multiply with the same thing. Now in the numerator, if you see, you get a data of the kind a minus b into a plus b. How? A minus b into a plus b. So what is a minus b into a plus b? A square minus b square. So this will be sine x plus h minus sine x whole thing divided by h into square root of sine x plus h plus root sine x. So in the numerator, the square root sign has been eliminated. Okay. Now if you check properly, the numerator is of the form sine c minus sine d. Instead of c I have x plus h, instead of d I have got x. So we'll try to use that trigonometry formula. If you want to revise all the formulas, you can watch my videos on trigonometry formula. I've explained you in very easy way. So What is sin C minus sin D? Try to recollect. It is 2 cos C plus D by 2 into sin C minus D by 2. So over here, what is my C? C is x plus h and D is sin x. So this will be 2 cos x plus h plus x by 2 into sin x plus h minus x by 2, and the denominator remains as it is, h into square root sin x plus h, the square root of sin x. So what we are going to do, we are going to simplify it further. So what we get? Limit h tending to 0, 2 cos 2x plus h by 2 into sin h by 2. Why h by 2? Plus x minus x gets cancelled. Upon, I'll shift this h over here. I'll explain you why. So first you'll write root sin x plus h plus root sin x, multiplying it by h. Now the reason for shifting h is that limit h tending to 0 sin h upon h is equal to 1. So we are trying to use this limit. Okay. Over here I have got h by 2. So I need to make an arrangement for h by 2 over here. That will do in the next step. So this is limit h tending to 0 2 cos 2x plus h by 2 upon square root sin x plus h plus square root of sin x into limit h tending to 0 sin h by 2. Now if I make this h as h by 2, I will have to multiply by 2 over here. Okay. So what will get? Limit h tending to 0 2 cos 2x plus h by 2 whole thing divided by root sin of x plus h plus root sin x. Take it aside, 1 upon 2, and this limit, which limit? This limit is 1. Okay. Now we'll apply the limit in the remaining part. So what is that? 2 cos 2x by 2 as h is 0 into root sin x plus 0 plus root sin x. That gives us 2 cos x, root sin x plus root sin x is 2 root sin x, cancel 2 and 2. What do we get? Cos x upon root sin x. That means derivative of root sin x is cos x upon root sin x. I hope the sum is clear to you. Let's move to question number 4. Question number 4. The function is x sec. That means f of x is x into sec x. So I need to get the value of f of x plus h. So what will be that? X plus h into sec x plus h. So I'm ready with f of x and f of x plus h. So let's write the first principle of derivatives, that is f dash of x equals to limit h tending to 0 f of x plus h minus f of x upon h. So first step, put the value of f of x plus h and f of x, then try to eliminate h. That will be limit h tending to 0 x plus h into sec x plus h minus f of x is x into sec x upon h. Just simplify this part. Okay, x plus h multiplied by sec x plus h. So simplifying it further, give you limit h tending to 0 x into sec x plus h plus h into sec x plus h minus x into sec x, whole thing divided by h. Bring x sec x plus h and minus x sec x together. Okay. Limit h tending to 0 x sec into x plus h minus x into sec x plus h into sec x plus h. Let us put bracket over here. Whole thing divided by h. Now the numerator, if you see, I have got a common factor x. So you can write this as limit h tending to 0 x into sec of x plus h minus sec x plus h into sec of x plus h, whole thing divided by h. Okay. Now we know that sec theta is 1 upon cos theta. If you get any kind of trigonometric problem, try to simplify the given function in terms of sine and cos, so that solving the sum further becomes easy for you. So I'll use the same over here. Limit h tending to 0 x. So I'll write this as 1 upon cos x plus h minus 1 upon cos x, bracket closed, upon h. I'll separate this part. Okay, h sec of x plus h upon h, and put a curly brackets over it. Now the numerator, I have 1 upon cos x plus h minus 1 upon cos x. So focus over it. We'll try to simplify this. That is limit h tending to 0. We'll keep x upon h aside for time being. So just cross multiply cos x minus cos x plus h. Cos x minus cos x plus h upon cos x plus h into cos x. H cancelled over here, so we are left with plus sec of x plus h. Why I am not simplifying this? Because h got eliminated in this part, so there is no need to simplify. But over here, h still remains here itself. It is not eliminated yet. In the numerator, we'll use a trigonometry formula now. Okay, cos x minus cos x plus h is of the form cos c minus cos d. Try to recollect what is cos c minus cos d. It is 2 sine d minus c by 2 into sine c plus d by 2. Don't forget this. I repeat, it is 2 sine d minus c by 2 into sine c plus d by 2. You can write this as c minus d as well, but over here I'll put minus. Okay. So what is cos c minus cos d? 2 sine d minus c by 2 into sine c plus d by 2. Apply this formula over here. So what's my limit? Limit h tending to 0, x upon h kept aside. That will be 2 sine. Instead of c I have x, instead of d I have x plus h. It is x plus h minus x by 2 into sine x plus h minus x by 2 whole thing divided by cos x plus h into cos x. Plus, what happens many times when you simplify the problem, you forget about the additional material mentioned, that is sec x plus h. Okay. We also need to close this bracket over here. So let's move further. This kind of simplification is similar to the question number 3 we did just now. This is limit h tending to 0, stay focused, x cancelled. Okay, that is 2 sine h by 2, say sine 2x plus h by 2 divided by cos x plus h into cos x plus sec x plus h. The limit is for this complete thing. Okay. This part is completely similar to the previous problem. Now I have sine h by 2. So I'll try to keep this h with that sine h by 2. Take this 2 aside. So 2 into limit h tending to 0, x into x into sine h by 2. I'll put this h over here into sine 2x plus h by 2 whole thing divided by cos x plus h into cos x plus sec x plus h, bracket closed. Focus on sine h by 2 for now. This is 2 into limit h tending to 0, x into sine h by 2. I'll just make this h as h by 2. So I'll have to multiply by 2 over here. Okay. Into sine 2x plus h by 2 upon cos x plus h into cos x into the bracket over here in plus sec x plus h. Look carefully, what happens? These two and these two gets cancelled. And this limit sin h by 2 by h by 2 will be 1. Why? Limit h tending to 0, sin h upon h is 1. Now just apply the limits. X into 1 into sin 2x by 2 upon cos x plus 0 into cos x plus sec x plus 0. Okay? Simplify it further. 2 gets cancelled. So this is x into sin x upon cos x into cos x plus sec x. And if you know basic trigonometry, what is sin x upon cos x? That is tan x. So x into tan x. And what is cos x? 1 upon cos x? Sec x. So x into tan x into sec x, whole thing added sec x. So this is the derivative of x into sec x using first principle. Let us solve different kind of problems now. Question number 5. If f of x is equal to 3x plus 2, then find f dash of minus 2. I need to know the value of f dash of minus 2. Using first principle. What's the important part over here? Using first principle. So before you find f dash of minus 2, what we need is f dash of x. Okay. What we need is f dash of x. That is f dash of x equals to limit h tending to 0 f of x plus h minus f of x upon h. For this, I need f of x plus h as well. So what is f of x plus h? Simply replace x with h. 3 into x plus h plus 2. So let's solve this some further. Remember, I need f dash of minus 2. For that, basic need is f dash of x. Okay. So f dash of x is limit h tending to 0. What is f of x plus h? 3 into x plus h plus 2. What is f of x? 3x plus 2. To avoid confusion, please put the brackets. Do not forget that. Upon h. Now, we will simplify the numerator and try to eliminate h. So what do we get? F dash of x equals to limit h tending to 0, 3x plus 3h plus 2. This will be minus 3x minus 2, whole thing divided by h. 3x cancelled, 2 minus 2 cancelled. So f dash of x equals to limit h tending to 0, 3h upon h. H's gets cancelled. So you apply the limit, what do we get? 3. So which clearly means that f dash of x is 3. Okay. F dash of x is 3. So to get the value of f dash of minus 2, I just replace x with minus 2. Since I don't have x over here, f dash of minus 2 will remain 3. So it is 3. F dash of minus 2 is just 3. That's it. Okay, I hope the sum is clear to you. We'll solve one more sum using the same kind. Question number 6. F of x is x squared plus 1. We have to find f dash of 2. Okay. Before you find f dash of 2, try to get the value of f dash of x, then replace x with 2. So I'll need f of x plus h for using the first principle. So what is that? X plus h whole square plus 1, which is x square plus 2xh plus h square plus 1. So let us use first principle now. What is first principle? F dash of x is equal to limit h tending to 0 f of x plus h minus f of x upon h. So this limit h tending to 0 x squared plus 2xh plus h squared plus 1 minus x squared minus 1, because we have minus over, that will be minus x squared minus 1 whole thing divided by h. Simplified further and try to eliminate the letter h. That will be limit h tending to 0. Watch, x squared minus x squared cancel, plus 1 minus 1 cancel. So we are left with 2xh plus h squared upon h. In the numerator we have a common factor. What is that? H. So this 2x plus h whole thing divided by h. After this apply the limit, what do we get? 2x plus 0, that is 2x, which means that f dash of x is 2x, f dash of x is 2x, and we are in the need of the value f dash of 2. That means I'll replace value of x as 2. So it will be 2 into 2, that is 4. So f dash of 2 is 4. Okay, I hope the sum is clear. Don't forget to copy the notes. Okay, now some questions for solving on your own. You can practice it. Okay, assignment questions. What are you going to do? You are going to find f dash of x using first principle. Question number 1, x minus 1 upon 2x plus 7. Question number 2, cos 5x. Number 3, cosec 3x. That's it. We'll stop here for today. In the next lecture, we'll begin with derivatives of standard functions like constant function, power function, etc. Stay tuned. Please like, share with your friends, and subscribe to the channel so that you don't miss any of my future videos. Thank you.